We are the RT600 group, and my colleagues are Jexler, Ching, and Christopher Hans ROVILLOS. We are here to present to you our final proposal. So, Chiroville Commercial Building is located at Capitol Road, Tagum City. It is a four-story building with roof deck. Steel is the main material that are used in the design and construction. The ground floor has rentable spaces, supermarket, and of course, a common toilet. Second floor also has rentable spaces, department store, food court, food stalls, and common toilet. And in third and fourth floor, it has rentable offices with different sizes and with own toilet. And in roof deck, it has two water tanks that can supply the needs of the entire building. The parking lot or the parking area of this building is located outside of the building.
So this is the building look likes. So next is the architectural plans. So first is the perspective. So as you can see, it is the front view of our perspective. Then next is the site development plan. I mean the vicinity map. So here, the vicinity map is located at the Tagum City Capital Road beside the RDR Gym. The next is the site development plan. So this site development plan look like. So our lot area is 15,000 square meters. Then our floor area is 2,000 or more square meters. Then our parking lot is, as you can see, it is outside the building. The next is ground floor plan. So ground floor plan consists of a supermarket, rentable spaces, minimum of 20 spaces, then a common toilet, a storage room, then an electrical and mechanical room. Then also it has lobby and entertainment hall. Then next is the second floor plan. So second floor plan consists also of department store, 20 commercial spaces, then it has food halls and a food court. So next is the third and fourth plan. So third and fourth plan consists of rentable offices. It has varied sizes, There are small, medium, and large. So it consists of adequate spaces provided in each offices. It has its own comfort rooms, and also it has comfort room outside. Then last is the our roof deck. So roof deck consists of the two water tanks that can supply the whole building. So next is our elevations. So first is our front elevation. So from ground to second, it measures 3.2 meters. Then same goes for the third to fourth. Then fourth to roof deck measures 2.4 meters. So next is the right elevation. So same sizes, then right, then left, and rear. So rear, as you can see, there is two fire exits at the back of the building. So next is the longitudinal section plan. So this is the longitudinal plan look likes. So next is the cross section, and also this look likes our cross section. Then next is the doors and windows schedule. So as you can see, we we listed the number of doors and windows we use in this building. So next is our foundation plan. So this is our foundation plan. So we assume that the footing one or the FC1 F1C1 is the footing one is the isolated footing. Then we design two columns FC1 and C2. So we designate here F1C1 and F1C2. F1C1 for the outer and F2C2 for the inner columns. So next is for the next is our framing plan. So this is our second floor framing plan. So we use the we use the one-way design for the framing plans, and then our my colleague will explain the critical section later and how we identify the critical section for this design. So next is the third and fourth framing plan. So it's just look like that. Then same goes for the roof deck framing plan. So here is our design of typical footing detail.
Start.
So here is the bottom bar and the top bars, the upper and the lower. So here we use
Engineer.
the 10 mm thick, well compacted fill. So next is the
Sad,
interior wall
sad na.
footing. So this is our design of the interior wall footing, then the exterior wall footing detail, and our tie beam in the typical footing. So
Next is our sad analysis model. So it will be
So
explained by
by
Christopher and ROVILLOS.
so uh, this is uh, wait. So this is our STAAD model. So as you can see, kana na siya. So, so first is the property. So here is our property for exterior columns, uh, 14 by 193. Uh, and next is in the interior columns is 14 by 233. In floor beams, 12 by 45, and in the girders for critical, I mean for Y is 16 by 89, and for I X day rather 16 by 89, and sa Y kay 18 by
Or why?
97. Mm. So our material is steel because steel is our subject. Diba? So steel.
Okay, tama. Next.
Next, specification. Uh, so here is our full release for the floor beams,
Start
start,
and end.
start and end. And here is our floor diaphragm,
Or the
uh, from from ground to second floor 3.4, from second to third 6.6, three from third to fourth 9.8, and lastly sa fourth to roof deck. So I will show you our re- 3D rendering pala. So this is our 3D rendering. Next is the supports. So we assigned all supports are fixed. So yeah. Next is the loading.
load.
So under the reference load definitions, there is dead load. So first is all the self weight. Next is let's compare it for to the load combination
Computation of load
computation of
computation.
load. So first, uh, 9.984 for outer walls, 3.32 for 3.42 for where's that?
Inner wall.
Inner
Ay, roof deck wall.
roof deck walls. Next is for the second floor inner walls. Here is our second floor inner walls, and this is second to I mean second, third, and this is for to roof deck. So for dead loads, here is our dead loads
Slab.
for slab. So for the second slab, second floor to
Fourth
fourth floor
floor.
is the same 5.163 here. And for the
For the
slab
slab of the
is 3.4895. So also sa stairs, second to fourth floor, it's all the same except sa roof deck. Next is our seismic definition. So our parameters in seismic definition is uh, zone is 0.4, importance factor is 1, R is 8.5, soil profile type is 3, and NA and NV is 1 and 1.2. So next
load
is
load
our
combination. Load
load
cases.
cases details. So first here is our primary loads. Seismic load for X positive, X negative, Z positive, and Z negative. Mm, Next, under here, under the dead load is the reference load. So naka-assign lang siya. Live load, uh, under under the live load is it consists for tawag dyan. Basta group na mo siya
We use
for
groupings
uh,
for
for
the
the
live
live
load.
load. So here is our depth store or
Naka-group siya lahat for the
space,
same.
rental spaces, toilets, and food court. As so and so forth din siya sa roof deck, hanggang sa roof deck. So next is uh,
The
will
fluid load.
ay fluid load pala. Sorry. Fluid load is our fluid load because uh, we consist din for two water tanks in that area. Next is our
Load combination.
load combination. So here is our combinations galing sa NSCP 2015. So uh, so kani gibase lang namo siya sa NSCP 2015. Kani naka-highlight diri sa among Excel sa load computation. So next,
Used to
and
run the
let's run the
model.
our model. So just take your time and wait.
Sige na,
Sa
Okay,
i-start
go.
nimo.
Oh, start na sa hands. Go.
So, here is our output. I mean our run analysis and design. So zero errors, zero warnings, and 14 notes. So let's view the output file and check the stored drift. So nag-set mig 0. I mean 25%. I mean 2.5% na limit for seismic drift for long and short buildings. So as you can see, pass siya tanan. Yeah. So next
So next would be the base plate design, ay the
next would
column design. So, so for the column design, first na mo gibuhat is to tabulate ang mga data from the SAAD. So, for the tabulation, nag-create me og for the exterior interior columns. So, different um, ilang section na nagamit. So, lahi po na mong pagka-tabulate. So, sa tanan beam within the critical frame is gitabulate na mo. So, para siya makita siya sa tabulation. And then, from that tabulation, ikuha na mo ang maximum o minimum sa start ug end sa column. So, diri matabulate po siya. And then, from that floor of the critical frame, ang tanan gikuha nga maximum ug minimum is gikuha na pod siya og another maximum and minimum para isa lang ang ma-design per exterior column. So muna ni siya ang makita dire. And then from 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 nakuha na ang ang absolute maximum og minimum sa start ug end is diretso na siya sa column analysis and design. So, diri sa column analysis is, for example, for the 1C1 or the ground floor na exterior column, we use the W14 by 193 section from the SAAD. And then, diretso na siya ma-tabulate diri ang iyang mga parameters. And then, from the tabulation, from the summary of the tabulation, i-input lang ang value sa maximum axial, maximum moment sa x ug y, and then the length is 3.4, the kx and the ky. And then from that, makita na diri ang final design whether it is safe and economical or you have to redesign. So for this for our column, ang giingon diri is safe and economical ang W14 by 193 na gamiton for this building. And same lang siya for the second floor, third floor, and the roof deck. So same process lang siya. So ang next is
So the design of our column base plate is based on our column. So the tabulation here, the MY and the MZ and PA. So first is we trial the section. So we choose first W14 by 193. So here, after you put the moments and the PA, it compute the M, the N, the N prime and the thickness. So here, it computes the thickness of 30 mm. So, and the N and B, it compute the 525 mm. So here, by determining the anchor bolts, the it gives the diameter of 50 mm with the 3 anchor bolts on each side. So same goes for the other base plate in the other columns. So next is the column. Next is the beam. So before we discuss the beam, we first discuss the critical
critical
the critical
frame.
section for the beams.
So this is our critical sections for our model. Wait. So in this part sa second to sa roof deck is same lang siya for critical Y here and critical X. So naadre among critical frame because in this section mag-occur ang pinakadako na or naga-exist ang pinakadako
Load.
na load. So comparing sons
That's why we
ay
decided
that's why we decided na sa
dara ang critical
dala among critical sa 4 for dx and sa letter E for dy.
y-axis.
So next here is our shear and moment. Maximum for critical y and x. So we also get the critical floor beam. Among critical is located critical floor beam is located here lang or between the letter D and E and for the floor beam between the 3 and 4. So next is the beam design thing.
So the next
Building
is
design.
the beam design. Here is our beam design. So before we design this, we first get the maximum moments for each beam. So in the X tabulation, we tabulate all X-axis beams. So here in the first, so after we tabulate the X, we get the maximum moment of 313 of all the beams and the load case for 12. So we put here the maximum moment in our Excel. So 313 and the moment at left and the center. So we get here, then it will be solved for the compact or non-compact and the use, and it will be used for the FB. So here we use 148.8 FB. So after this, it will solve also the deflection, the max moment for the for the design. Then at then in the combined axial and bending stress, it will it will prove that safe or unsafe. So here it shows that it is safe for this section. Same goes for the Y. We get all the maximum maximum moment. So in Y we have a floor beam. So in each floor beam there are two beams. So we tabulate the two beams and we choose the maximum beam. So here we choose the maximum beam here, also the 476. So we input here in our Excel the values. Then same, it will also solve the compact or non-compact for the allowable bending stress, then the check for the support, check if the section is supported or not, then it is supported. Then at last it will solve if it is safe or unsafe. The FBX over FBX must be less than 1, so it is less than 1, so it is safe. So last is the design of floor beams. So here we also tabulate the floor beams. It is in the x-axis. So here this is the maximum moment for the floor beam 113. So we input here in our Excel. Then it is same process, and it will also less than 1, so it is safe. Then lastly, design for
So the slab.
design for the
Slab detail.
slab. Wait. So, so here is the design of our slab, the details. So span next to end span or one way. So this is our design of slab from second to roof deck. So we use the concrete F prime C 28 MPa, then the steel type which A36 or FY 414 MPa. So concrete weight 23.56, then the span length is 6, then the shorter span is 3, then the thickness used or H is 125, the width is 1 meter or 1000 mm, then the clear cover for the main steel is 20 mm. So here the dead load, we use the superimposed dead load which is 1.98 kN per meter, and we get the self weight. So in getting the self weight, we multiply the concrete weight times the thickness used over 1000, so we get 2.95 kN per meter squared. So here the live load, we use the 6 kilometer I 6 kN per meter squared. Then the total dead load is the sum of this superimposed and the self weight, so it is 4.93 kN per meter squared. Then the total load use is, or the WU is just 1.2 times the dead load plus 1.6, and the live load, it is 15.51 kN. So here the design of flexure or the MU, so WU times L squared over 8, then it will solve 69.817. So the effective depth is 100, then the steel ratio is 2.357, then the raw mean is 0.338, the area of steel is 2,357 mm squared, then the bar diameter we use is 10 mm, then the required spacing is 30. So in the temperature steel, it is 0.18% of the ratio reinforcement, then the required area of steel is 225, then also bar, the bar diameter is 10, and the required spacing is 340. So here in the summary, we use the bottom steel 10 mm bar at 30 mm spacing from center to center. Then in the temperature steel, same same 10 diameter bar at 340 mm spacing center to center also. So lastly is our conclusion.
So for the conclusion, this four-story commercial building has been analyzed and designed. All the results of analysis and design are found to be safe. The limit state method of design is used for design to all the components. This method of design is considered to be the other met- better than the other methods available for design, particularly for buildings. From the design result, it has been concluded that this design can be adapted to any commercial building. So that's all. Thank
So that
you.
will be all.
Thank you,
Thank you,
sir.
sir. Merry Christmas and
Thank you,
advance
sir.
Happy
Merry
New Year.
Christmas.
Merry
Merry
Christmas,
Christmas,
sir. Happy
all.
holidays.
Okay.